So we were looking at sketching the graphs of things. So this was still that like 10.1 part 2 continued. And so, for example, sketch the graph. Okay, so A, R equals 2 cosine of 3 theta. So again, these are, you're graphing in polar. So you're taking a polar equation, but we're graphing it on the XY axis. So kind of like we did last time, right? So we're going to have this big graph where we're graphing stuff. But to help us figure out how to actually make that graph, the first thing I want to do is I want to think about graphing if I were to just graph y equals 2 cosine of 3x. So to help us remember, the 2, right, that changes the amplitude. So if you were talking about drawing the general cosine curve looks like this, right? So we're going to have some of them going out here. Usually it's one high and one low, but in this case, because we have that 2, it's going to be 2 high and 2 low. And then the 3 changes the period, right? So the period is now going to be 2 pi over 3. And so that means one cycle, so how long it takes the wave to start here, come down, and come back up to that same starting spot is going to, used to take 2 pi, but now it's going to take 2 pi over 3. And in general, when you're graphing these, you want to make your axis here go all the way out to 2 pi. So we're going to have to do some more work to figure out, like we might need to draw more iterations of this curve. I personally, so since all the way out is 2 pi, this point here is halfway out, and so that would be 2 pi over 3 over 2. So half of 2 pi over 3 is just pi over 3, which means then this point here is pi over 6. So basically our points along the curve are going to be pi over 6s. So we have 1 pi over 6, 2 pi over 6. This would be 3 pi over 6. Remember, 3 pi over 6 is pi over 2. This point here, which is 2 pi over 3, would be 4 pi over 6, but 4 pi over 6 is 2 pi over 3. We have here, we're at 5 pi over 6. Here, this would be 6 pi over 6. 6 pi over 6 is just pi. This is 7 pi over 6. We're back here to the beginning. That's 8 pi over 6. But 8 pi over 6 is 4 pi over 3. And I need to at least do one more iteration of that wave. I'm trying to get out to 2 pi. So I had 8 pi over 6. We're going to have 9 pi over 6. But 9 pi over 6 is, divide both by 3, it's 3 pi over 2. Here, this is going to be 10 pi over 6. But again, I can reduce that. 10 pi over 6 is 5 pi over 3. This is 11 pi over 6. And then finally, here we are at 12 pi over 6, which is 2 pi. So I've gone all the way out to 2 pi. And that way I can kind of figure out what is happening in my XY plane. So that's the first step. Your first step is just to graph it like, and this graph that I just did here, that is what you would have done in Math 127. So pre-calc 2. So it's just a straight up pre-calc 2 graph. Then what I do is I look and I go, okay, well, I'm dealing with pi over 6s. So I want to think about splitting my graph here into pi over 6s. So pi over 6, remember, is 30 degrees. So this is pi over 1 pi over 6. So since it's 30 degrees, it would split this first quadrant into 3 pieces. This is 2 pi over 6, which is pi over 3. Here we're at pi over 2. And again, if I split this quadrant So I'm at pi over 2. This then is that 2 pi over 3, right? Because it is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6s. This is 5 pi over 6. This is 6 pi over 6, which is pi. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. 11 pi over 6. And then finally, we're back at, this was 0, and now it's also 2 pi. Okay, so I have the setup ready to draw my curve. Does anyone have any questions on anything I've done so far? No? Okay. So now this is where I began to take the points, right? So if I take this first point, it's 2 for the radius and 0 radians. So that means we're going to go out a distance of 2. And so that red point there is going to correspond to this red point here. And then my next point, I'll make that one blue, at pi over 6, so on this spoke here, we're at a distance of 0. So we're back in here at the middle. And so we did this last class. You just kind of make a curve that goes between those two. So kind of like a flower petal. You're staying in that triangular wedge between the two. So basically this is that first thing of my curve, right? And I put the direction there so we know kind of how we went. So we started out there and we went in. The next point is going to be down here. So we're on the pi over 3 wedge, right? The pi over 3 spoke. However, I'm down here at -2. So since I'm on the pi over 2 spoke, but I want to be at -2, rather than going out 2 on this spoke, we're going to go out 2 on the opposite spoke. So this brown point is going to come out a distance of 2 on that spoke. And so we're going to end up going in like that. Questions so far? No. Sure. So, are you okay with how I did like going from the red to the blue? So like I put the red, are you okay that the red point went here and the blue point went here and I arced my way in? Okay. So now if you think about this brown point here, this brown point has a radius of -2 and it's pi over 3. So when you go out on a spoke, when you're going out this way from the center on a spoke, you're going out the positive direction. But at pi over 3 on this spoke here, rather than go out the positive direction, I want to go out the negative direction. So the negative direction is just going to be the opposite direction. So I'm going to go backwards to this way. So that's how I end up there. Does that help? No problem. Other questions? All right, so let me get another color here. Let's pick purple. Let me get a little more purpley. Okay, so my next point here, right, should be there. So at pi over 2, I'm back in at 0. So we're coming back in here. So we're starting from this brown one and coming back in. Go for the lime green here. So my next one at 2 pi over 3, right, I am back out at positive 2. So at 2 pi over 3, I'm going to go out 2 on that spoke. So now we're talking about sliding that way. And then, let's see, we'll do a yellow one. Here at 5 pi over 6, I'm back in at 0. So on 5 pi over 6, I'm back in at 0. Isn't what, are you asking the green one? Okay, so the lime green one is not negative 2. So the reason why the lime green one is not negative 2 is so basically I have like tick marks on each of these axes, right? And we're not thinking of these as positive. So it's not a literal translation of like, oh, the left side of a graph x's are negative and the right side of a graph x's are positive, right? What we're saying is I was on the 2 pi over 3 spoke. So on this spoke, I go out 2, right? If the radius, anytime it's negative, rather than go out on that spoke, I go the other direction on the opposite spoke. No problem. Other questions? Okay, and then I think we need one more color here. So I'm going to do this turquoise. So at pi, right, we're at negative 2. So here I am so here's the pi spoke. But since I want to go negative 2, I'm actually going to end up back over here where this red dot was. So we're going to end up here. And we're curving that way. And what you'll actually see after this is that the graph will actually, since I went back up to where I started, as I do the next points, right? So if I did 7 pi over 6... I would come back in. So I end up traveling around this curve 2 times between 0 and 2 pi. So that is the curve. So once you get your flower closed up, you're usually done. But if you went through and kept doing more of these points, we would do the exact same thing we did before. So we would come back in. Then at 8 pi over 6, which is 4 pi over 3, we're going to go out to 2. So we'd come back out here to the brown point. Then we come back in. Then at 5 pi over 3, here we would be at negative 2. So we would be back over here. So we'd go back up to the line green point and then back down. Why wouldn't... So it is negative. So again, you don't want to think about negative as being like, oh, on this side I'm positive and on this side I'm negative. So this turquoise point says, go to the pi spoke. So here's my pi spoke, right? And then it says the radius is negative 2. So rather than go out 2 on the pi spoke, we're going to go backwards 2, right? That's what going backwards is taking care of the negative. So the negative is saying go backwards on the spoke. When it's positive, it's saying go out on the spoke. Yeah, it's like saying go in the negative direction, go in the backwards direction. Does that help? No problem. Other questions? No. Okay. Should we try another one? So B r equals 2 cosine theta plus 2. So again, here's my big graph. But we want to graph y equals 2 cosine theta plus 2. So kind of to remind ourselves, right, if I first just graphed 2 cosine theta, right, 2 cosine theta, it's pretty similar to what we just did, right? Oh, yep, I definitely can go back a second. I can eat my cheese stick while you guys are still doing that, since I didn't get to eat lunch. Okay, no problem. So we're looking to graph y equals 2 cosine theta plus 2. Yeah, I should have written it as an x, yes. It doesn't really matter. It's just my rough sketch for me to know what's going on. So if you wrote x's or you wrote thetas here, it's not a big deal. So 2 cosine theta or 2 cosine x looks like this, right? Similar to what we just did. The amplitude would be 2 and minus 2. The period would be 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. So I have 1 pi over 2, 2 pi over 2s, 3 pi over 2s. And then this plus 2 here takes that entire graph and raises it up 2. So rather than going between minus 2 and 2, the graph is now going to go between 2 and 4, right? And the middle will now be here. So it's going to look like this. Here's 2 pi. This point is still 3 pi over 2. This is still pi. This is still pi over 2. So, questions on that? Does that make sense? Okay. So, then my first point here is going to be 0 degrees. And you'll notice I didn't have to like make any of those dotted lines for my angles because my angles are just these right here, right? 0, pi over 2, pi, 3 pi over 2, 2 pi, right? Those are the angles I'm dealing with. So that blue dot is at a radius of 4. So we're going to go out 4 on the 0 spoke. And then this teal dot, to make the teal dot, we're going to go to the pi over 2 spoke. So here's my pi over 2 spoke. And we want to just go out 2. So the teal dot is going to go there. And then we're just looking for a curve between them. My next dot is here at pi. So on the pi spoke, we're going to come back in to 0. So it's going to curve out and back in. And then the line green. My line green dot here. So we're going to go on to the 3 pi over 2 spoke. And we have to go out 2. So we're going to, my lime green dot is going to end up here. And sure, we'll do a red dot. So my last dot here, we're going to be on the 2 pi spoke and back out a distance of 4. So we're going to go back to where we started. Right? So this is what's known as a cardioid, right? And the reason it's called a cardioid is because it looks like a heart, right? I mean, it's a sideways heart, but still it looks like a heart. Questions? It's not too terrible, right?
I have a question.
Sure.
Dr. Gordon.
Sure.
So, I saw that like we started at the x-axis at 4, and then we went up to 2 axis. We went up there because it's pi over 2.
So, yeah. So we went. So 2 things. So think about. You want to think about this teal point here, right? If I had to label this point here, it would be the point pi over 2 comma 2, right?
Yeah.
Okay. So what that is saying is the first thing is telling you which spike to go on. So go to the pi over 2 spike. The second tells you how far out on that spike to go. So this says go to the pi over 2 spike and go out 2. So here's the pi over 2 spike, and we're going to go out 2 spots. So that's why I put that there.
I see it. Thank you so much.
No problem. Other questions? No. Okay. Does anybody need me to wait before I do another one? I know. It's a good thing for Valentine's Day, right? I'm telling you. So you could just write. I told you my story from last time, right? We just wrote on the bottom of my girlfriend's wine glasses, R equals 2 cosine theta plus 2, right? And then she's math, so she knew they were a heart. Okay, so let's try another one. R equals 1 minus 2 cosine theta. So, again, we're going to have this here. We're going to draw, so 1 minus 2, so y equals 1 minus 2 cosine x, right? So if I were to draw minus 2 cosine x, right, it would be that curve we just did but flipped over, right? So here you are at minus 2, 2. And then, again, these are like those kind of 5 points I keep worrying about. And so now we're going to take those 5 points and shift them up. 1, right? That's what that 1 does. So we're now going to go, excuse me, up here to 3. Our graph is going to be centered here at 1 now. I'm going to be down here at negative 1. So that point, this point here went up 1, goes up 1, right? Goes up 1, goes up 1, goes up 1. So you're talking about, kind of looks like that. And this point here was at 2 pi. This is pi. This point here is at pi over 2. And this point here is at 3 pi over 2. Now, there's two other points that I don't know exactly what they are without doing some algebra, this point here and this point here. I just want to keep them in mind, though, that they go into 0. So it's some number slightly smaller than pi over 2 and some number slightly bigger than 3 pi over 2. Okay, so I label my axes here, right? 0, pi over 2, pi, 3 pi over 2, so forth. 0, 2 pi. Okay, so if I take my first point, right? So my first point, I am at 0 degrees, and at 0 degrees, I'm at -1, right? So if you remember, negative means go the opposite direction. So rather than go out here to 1 on the 0 spoke, I'm going to go to 1 in the opposite direction. So that's where that first red dot is going to go. My next red dot is going, or my next dot is going here at pi over 2. We're going to 1. So here's 1. And we're going to pi over 2. Okay. So what people want to do with this at this point is they want to go, oh, look, I could just make a nice little curve between these two. Okay. You can't make a little curve between these two because you are not traveling, the blue dot was second and the red dot was first. So we are swinging. And if you notice, when I did all of these, right, that first swing in that first quadrant, you're always going in a counterclockwise motion, right? So you're trying to swing counterclockwise. Well, if you notice here, I can't swing counterclockwise. If I do this, that's it's counterclockwise, but it's going from the blue dot to the red dot, and I have to start from the red dot. So I can't go this direction because I would be going clockwise, and I want to be going, you want that first, you want your movements to essentially be kind of counterclockwise in terms of how if you think of like a particle moving. Okay, so that means I have to swing from this one to this one. And so it's kind of weird, but actually what you end up doing is you end up going like this. So it's like you're making a curve. You're essentially making a curve in the space between those two dots. So if you think about it, and this is where, like, teaching this online this semester stinks. I'm just going to say that because it's terrible to do this because I never realized until I started teaching this last class how much I use my hands pointing on the graph to be able to show you guys things. And my little, like, pointer here just does not have the same effect as my hands to be able to block stuff off and show things on this. So after last class, I was like, oh, this stuff is not the greatest. So because of that, I am actually going to, like, tell you guys that in terms of the stuff we're doing today being on the final exam, I might put it on the final exam, but if I put it on the final exam, it'll be like as a bonus question. So I'm not going to make you draw any of these things by hand on the final exam, unless, you want to attempt a bonus question. Just because, like, my delivery of these is not as good as it is in the classroom. So I'm just going to put that out there. So the idea is, like, the space you have from this red dot to this blue dot is all of this area, and that's why I'm, like, going through that entire area space. Okay, my next dot is at pi. I want to go out 3. So remember, this was 1, so we need to go out 2 more. So we're on the pi spoke. We're going here to 3. So you're coming this way, right? And there I can just go in that direction because it's easy for me to go counterclockwise from the blue dot to the green dot. And then the next one here, the yellow dot. So the yellow dot is at 3 pi over 2. We're at 1. So we're talking about doing this. Oops, I should have actually made the yellow dot. Okay, and then finally, like a lime green one. Here at 2 pi, right, we are, at 2 pi, we're here at -1. So on the 2 pi spoke, I have to go back the other direction. So I'm back here on top of the red. And this is going to go the same way. It's going to cycle in to that clockwise. So you get another, this is also a cardioid, but this cardioid has a little thing that's like a little hangy thing in the middle. Questions? No? Okay. So then the last thing that we're going to do, and I'm just going to show you one example because again, this is not, I'm not going to, and we'll talk about it. So you can find, so this is from section 10.3, and so you can find the areas in polar coordinates. So all the things that we've been doing so far are these like kind of curved areas, right? And so the formula for the area, and we could derive it, but I'm not going to take the time here to derive it, would be the integral from a to b of 1/2 r squared d theta. So, for example, let's find the area of one petal of the rose. R is equal to 3 cosine 3 theta. So in terms of a picture, right, if we were going to actually draw what we were doing here, so that you kind of had like a picture of what was going on. So 3 cosine 3 theta, right? So cosine 3 theta is going to start to look like this. This point up here would be 3. This down here would be -3. The 3 theta changes the period, right? So it's 2 pi over b. So 2 pi over 3 is our new period. So that means this point here is 2 pi over 3. Half of that, pi over 3, pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, or pi over 2. And we keep going like we did earlier. But really, I just need to see like what one petal of the rose looks like. So if you think about, here's my pi over 6 spoke. And if we think about graphing these, so this red one would be out a distance of 3 on the 0 spoke. And then this green one here goes into pi over 6, but it's 0 in terms of the radius. So it looks like that. And I think this is probably that same one I graphed at the beginning of class, right? Isn't it, I think? Maybe? I did 2 cosine of 3 theta. This is 3 cosine of 3 theta. So this area right here, that's half of a petal, right? Eventually the petal will come back around and form the other half. So we can use the some symmetry laws to help us out here, right? So it's half of the petal. So we could find the area of half the petal and then just double it, right? So we're going to find the area of half the petal. Does that make sense so far? Okay, so to find the area, all we're going to do is plug into our formula here. I should have really said this when I wrote this formula, but A and B here are angles, right? I'm doing d theta, so we're talking about when you're going from one angle to another angle. So to get this petal down here, what angles did I go from? I went from what angle to what angle? Yeah, I went from angle 0 to angle pi over 6. And then the formula is 1/2. R is 3 cosine 3 theta squared d theta. Right, so I used that formula I gave, and I basically wrote down what that is, right? So if I kind of work this out, we're going to end up with the integral from 0 to pi over 6 of 1/2 9 cosine squared 3 theta d theta. So I can factor the 9/2 out to the front. So 9/2 the integral from 0 to pi over 6. Does anybody remember from back when we did the techniques of integration, cosine squared, anybody remember how we integrated cosine squared, what we used? Okay, so you could absolutely replace cosine squared with 1 minus sine squared, but then you have to integrate sine squared, and we don't know how to do that. So there was something else we used. So there's something we used anytime we were trying to integrate sine squared or cosine squared. Yeah, the half angle formula. So remember, the half angle formula says that the cosine squared of x is equal to 1 plus the cosine of 2x all over 2, right? So instead of an x, we have a 3 theta, right? So our 3 theta here is acting like our x. So this is going to be 1 plus the cosine of 6 theta all over 2 d theta, right? Because it's 1 plus the cosine of 2x, and in this case, x is 3 theta. So I could factor that 2 out in front. So this is going to be 9/4 times the integral from 0 to pi over 6 of 1 plus the cosine of 6 theta d theta. So we're going to have 9/4. So what's the integral of 1? Yep, theta. What's the integral of the cosine of 6 theta? Not 6 sine of 6 theta, but close. So it definitely has the sine of 6 theta, but it's not, 1/6. So 1/6 the sine of 6 theta from 0 to pi over 6. So remember, since I'm integrating it, it's going to be positive because the derivative of sine is cosine. So if you were taking the derivative of cosine of 6 theta, then it would be minus. But the minus comes when you integrate sine, not when you integrate cosine. And so now I just have to plug in here. So we're going to have 9/4 times pi over 6 plus 1/6 the sine of 6 times pi over 6 minus 0 plus 1/6 the sine of 6 times 0. So 6 times 0, right, is 0. So you're looking at the sine of 0. Here, 6 times pi over 6 is pi. But the sine of 0 goes to 0, and the sine of pi goes to 0 as well. So we really have 9/4 times pi over 6. And so that is going to be 3 goes into 9. 3 times 3 goes into 6. Whoops. 2 times. So this is really going to be 3 pi over 8. And remember that was for half of the petal. Whoops. So the whole petal is going to be 2 times 3 pi over 8, or 3 pi over 4. Questions? No. Does anybody need me to wait before I go on? No. Okay, so what I'm going to do here, give me a second to pull it up. I am going to pull up our class in Canvas so that we can talk about the final exam. So let me share my computer screen here. Okay. So I have here, under the test review page, right? So if you go from Canvas from our homepage to the test review page, you will see the final exam and the review sheet. So if you click on the review sheet, it will bring up the review sheet here. Okay, so one of the biggest things on our final exam is being able to do the integration, right? So the integration stuff, that's the stuff that was on the first test, right? So being able to do all the different types of integration, then to be able to do all the series stuff. So that's the stuff off of the last test, which you guys should have realized. I should say the integration was the first and the second test, right? And then the series stuff was the third test. So those are the biggest. Those are the biggest things. I have put up on, or I did finish, I don't know if you guys saw it, but I did finish grading all your tests the other day. So all of your tests have been graded. So being able to do the series stuff. So being able to, all of the other stuff on here is totally fair game too, except the stuff I'm not going to ask you is, I'm not going to ask you to sketch the parametric curve, and I'm not going to ask you to find the areas, right? So in terms of the numbers, so those would be the problems that would potentially be a bonus question. I might ask a bonus question on the final exam. So they would be the problems like, I guess I should be careful. I'm not going to ask you to sketch I might ask you to sketch a parametric curve. I'm not going to ask you to sketch a polar curve. I said the wrong one. So basically the only thing you have to ignore on this review sheet, everything on this review sheet is fair game except for number 25. So number 25, I'm not going to ask you about. I'm not going to ask you number 25. So we won't do any areas. You won't have to do, I am going to upload them. So sometimes they just take a longer time to, buffer and stuff onto, YouTube. And then it's been a crazy day. So I haven't gotten a chance. It finally finished it last night. And so I have it ready to go. I just didn't put it up yet. So yeah, after class, I will put up the notes from last class. No problem. And then I will get today's up as well. Hopefully maybe today if it finishes. If not, tomorrow I will get today's up. So number 25 on the review sheet is the only one. So don't worry about number 25. Everything else on the review sheet is fine. The final exam will cover stuff through what we did last class, but it won't cover any of the sketching of the polar roses or the cardioids or anything like that. It won't ask about the area like the one I just did. But I might sketch this, polar graph, as a bonus question. So just so we're kind of clear about that, right? And then in case anyone was not in class last week, so this is the end of material for our class on not Monday. Our class is Tuesday, Thursday. On Tuesday will be, I will answer questions and review for the final. So anything you want me to go over, anything like that, that's what we're going to do on Tuesday. And then next Thursday, Brian is actually going to run an SI session during class, because I will not be here next Thursday. But I'm available. Yeah, so the bonus question would be for extra credit on the final exam. Yeah. So at the later part of next week, like if you have questions or stuff like that, you can totally feel free to email me, and I can, meet with you. I will most likely still have office hours the Monday of finals week. So if you have questions, you can pop in to those office hours the Monday of finals week. But then our final is Tuesday of finals week. Questions?